Hello, hello. Let's go ahead and go over these answers for the group work, or for the worksheets, excuse me. So let's start here. It says, are the following derivatives correct? If not, correct them. Okay, so you should have gotten that all of these were incorrect. Let's start off with this one. This one, recall that while for this derivative, you do get 12x, and you do get minus 7. The issue is that we need to remember that it's 1 minus that power. So it's going to be 3 or 12x to the 3 minus 7. Sometimes in the usage of power rule, we tend to forget to include the power, especially since you'll probably see a lot where we're doing the derivative of x squared. So just keep that in mind, okay? For over here, you can argue, that this is a product of f of x and g of x. And f of x and g of x, their primes respectively are 4x minus 1 and 2x minus 3. However, the technicality here is that it's not just going to be a product, right? Oh, well, okay, it's not a typo, but I meant to write minus 3 because the trick here was that you would think, oh, you just multiply their derivatives. But remember, you have that pattern of having f and g multiplying together plus f and g ah, multiplying together, where one has a prime and the other one has a prime. So the answer should have been 4x minus 1, 2x squared minus x plus 3, plus... Oh wait, I copied that down one. I copied f of x instead of g of x. X squared minus 3x plus 2. And then we have 2x squared minus x plus 3 times g prime, which is 2x minus 3. Over here, you can correctly clock this as f of x and g of x. But remember that the product rule isn't just you doing f prime, which, although correctly is noted 2x minus 1, and g prime, which is again correctly denoted as 8x. It's not just you doing the derivative of them. It's you setting it up as first f prime of x times g of x minus g prime of x f of x all over g of x squared. So you should have had something to the effect of 2x minus 1, 4x squared minus 3 minus 8x, and then x squared minus x plus 1. All over 4x squared minus 3 squared. All right. Here now we have match each situation with the correct description. So this is moving forward, speeding up, moving forward, moving backward, speeding up, moving forward, slowing down, moving backward, slowing down. Well, remember, we said that the pattern between speeding up and slowing down is that the signs are matching. So that means this guy has two possibilities. It can either be where these signs are matching over here, or these signs are matching over here. Same thing over here. These signs are matching, or these signs are matching. Slowing down is when they have alternating signs. So the possibilities are here and here, and the possibilities are here and here. So that's for speeding up, slowing down. But now moving forward and moving backward. Recall that moving forward means that the velocity is positive, and moving backwards means the velocity is negative. So we can eliminate one of these options each using that fact. Let's start with what I've colored in pink. Moving forward. So moving forward. So that means the velocity is positive. So this pink line is going to be incorrect. Now we're using orange. Moving backward. So that means the velocity has to be negative. So that means this guy, this orange line is going to be incorrect. Then we have moving forward for the slowing down options. That's when the velocity is positive. And then moving backward, the velocity is negative. So now we've eliminated one answer, and all of these connect to one. Okay. Alrighty, I'm just gonna retouch up these lines because in the process of eliminating the options, I technically erased some of the cartons. Okay. All right. Last one, but this one is a doozy. A particle moves along a coordinate axis. Its position is given by s of t, which is equal to t cubed minus 6t squared plus 9t. A, find the velocity. B, find the acceleration. C, find all the times the particle is at rest. D, find all the times the acceleration 0. E, F, G, and H um are all of the featurettes of using the number line that we did in our notes. Let's go ahead and just go piece by piece. I'm going to do A and B first. So we have the derivative of s of t, which we know is the velocity. And that's going to be t cubed prime minus 6t squared prime plus 9t prime, which is 3t squared minus 6t plus 9. Then recall that for the velocity, 3t squared minus 6t plus 9, it's the acceleration prime. So that's going to be 3t squared prime minus 6t prime plus 9 prime, which is just 6t minus 6. And that's going to be for the acceleration. I'm getting another pen. Now let's do C and B. Find all the times when the particle is at rest. Find all the times when the acceleration is 0. So this is basically us just solving for 0 for both sides. C and D. For velocity, we have 3t squared minus 6t plus 9 is equal to 0. We have the technical luxury of factoring out the 3 again. So that's what I'm going to do. 3t squared minus 2t plus 3 is equal to 0. From here, you can use the AC method or whichever you like. But you should have gone t minus um wait, not t minus 1. Oh yeah, no, yeah, you do get t minus 1 and then t minus 3. Wait. Give me a second. What did I do? Oh, that's funny. Okay, never mind. I have a typo on my key that I let slip in. Okay, well, either way, if that. No, I don't have a typo. I made a mistake. Oh my gosh, how silly. I made a mistake. That's what I get for trying to speed through this, maybe. I apologize. It's 6t squared. So it's supposed to be 12t. It's a good thing that, well, it's a good thing I do it twice before, but even then I still mess up live. I apologize. Okay, so that's going to be 12, and then that's going to be 4, and then my answer choices do make sense. T minus 1, T minus 3. So that means our zeros are 0, are 1 and 3. Now for the acceleration, that's just pretty plain to see. That's going to be when t is 1. Oh, but then I messed that up too. Oh, sorry. 12, 12, 12. Okay, so that's not as obvious. Let's go ahead and just do it a little bit. I mean, I think, yeah, the answer's 2. The answer's 2, but let's still solve for it anyway. So add 12 to both sides, divided by 6, 2. Yeah, okay. Just making sure. All right, and then E, F, G, and H. Okay, so they're all kind of going to stack on top of each other. Let's start off with a number line. Um, let's go from that be 0 to 1, 2, 3, and then 4. We technically don't need to go further because of what's going to be here. So let's start off with actually can I color code the same way that we have in our copy, or did I ruin that with my choice of colors already? Oh, we use purple and sky blue. Okay, I did not ruin that. Okay, so let's do the velocities. And we know that the zeros for the velocities is 1 and 3. So from here, here, and here, we have to test it. So let's test, um, is it legal to test 0? It's okay to test 0 in this specific instance because for 0, this function exists. Because remember, it's going to be a U shape, so it's kind of a regardless. As long as we check to the left of 1, it just looks silly because of what our domain is. We know that t being 0, the object is not moving at all. So it's kind of like improper in that way. Um, but let's just stick to like our classic idea. So let's instead of 0, let's use 1/2. Okay. So let's see. V of 1/2. I get 3 times 1/2 squared minus 12 times 1/2 plus 9. That's gonna be 3 over 4 because that becomes 1/4 minus 6 since that's just even, or since that just works right away, and then plus 9. From here it's pretty safe to say that we're going to have positive values to the left of 1. Checking between 1 and 3, that's easy, it's just 2. So all I'm doing is plugging it in. Let's see, 3 times 2 to the square, which is just, that's just 12. Okay, 12 minus 24 plus 9, that's gonna be, we know that's gonna be positive. We know this, we can just get exactly. Sorry, I yawned. That's gonna be -3. And that, well, is negative. And let's check to the right of 3. Let's just use 4. 3 times 4 squared minus 12 times 4 plus 9. That is going to be, okay, I'm just going to write out 3 times 16 minus 48, not 24, 48 plus 9. 3 times 16 is that 48 as well? Let me double check it just in case. No, that is 54. Okay, good. It's a good thing I double checked it. So 54 minus 48 plus 9. I'm not even going to bother. We know that for sure this will be positive. Okay. So we can technically, with this information, answer E and F. It says on what intervals is a particle moving to the right, on what instances of particles moving to the left. So forward and backward. So to the right, the particle is moving to the right from 0 to 1, and then from 3 to infinity, and then the particle's moving to the left from 1 to 3. Okay? Now G and H. What interval is the particle speeding up, slowing down? So for that, remember it's the idea of checking if the sign value, or if the sign SIGN values are the same or opposite. So we need to stock the acceleration on top of it, which is really just us testing around 2. And you can, this part I will skip. To the left of 2, we know that that will be negative, and to the right of 2, that will be positive. So we see here that initially it is indeed slowing down from 0 to 1, and then it starts being the same positive value from 1 to 2. So I'm going to start 1 comma 2. And then it's not moving at 2 because it's 0. But then from 2 to 3, they have alternating sign values. So that means slowing down. And then 3 and beyond, they have the same values. So it's moving, or it's speeding up. So just a recap, in case I misspoke, we start here and we see from 0 to 1, they are alternating, so they're slowing down. And then from 1 to 2, they're both negative, so they have the same value, so they're speeding up. Then from 2 to 3, they start alternating again, so it's slowing down. And then 3 onwards, they have the same values, so they're speeding up. Okay? Alright, this wraps up the worksheet. Let me know if you guys have any questions, and I'll see you all in the next video. Bye bye.